Thank you for taking the time to join us today. Our session will be focused on research with teachable robots. We would like to introduce our team to you. So I'll start. I am Dr. Cassandra Kelly. I am the Broader Impacts Project Coordinator at the University of Pittsburgh, which we'll talk a little bit more about today. But previously, I was in the classroom. I worked as an educator in elementary school settings, and then I've also worked in higher education supporting pre-service teachers for the past 15 years in different capacities with education. And I'll kick it off to Serena.
Hi everyone, my name is Serena. I am a junior at the University of Pittsburgh. I'm studying computer science and media and professional communications, and I've been working with Cassandra on this project and in the Broader Impacts office for a little over a year and a half now. So we've been making progress on this for a while, and I'm excited to show it to you all today. And then I'll just hand it off to Denise.
Hi everyone, my name is Denise Thomas Unal and I'm a PhD candidate in Intelligent Systems program at the University of Pittsburgh. My work looks at building predictive models of student behavior and cognitive states, and I do research on educational data mining. And I've been working with Cassandra on the broader impacts part of the educational data mining project for the past year now.
Thank you. And part of our collaboration with the University of Pittsburgh is also working with CIRCLS, which is the Center for Integrative Research in Computing and Learning Sciences. CIRCLS was founded by the National Science Foundation. They're supporting NSF awarded projects in the area of research on emerging technologies for teaching and learning. It's called the REDL program. And the community consists of researchers, emerging scholars, and educators. So one of our sub-communities is Educator CIRCLS, and we focus on bridging research and practice, which is why this workshop is being presented today. So we're going to talk to you a little bit more in depth about the workshop and this idea of broader impacts. So again, I mentioned my role as the Broader Impacts Project Coordinator. And Broader Impacts is actually a requirement for grants provided by the National Science Foundation. And the goal behind them is to disseminate the research to a broader audience so that we can actually have a societal impact. And so one of the aspects of broader impact work can be educational outreach, which you might have heard of, where the goal is to impact students. So there's a lot of computer science initiatives right now with the aim to bring computer science programs into classrooms with students. There's policies and legislation, and some of them are also geared more towards STEM and others more towards computer science, but that's just an example. You might also hear about it in engineering and other STEM-related fields, but it's not limited to that. So the idea is to broaden participation of underrepresented populations by introducing students to these concepts. So bringing it not just from the researcher level, but to the practitioner level and also to the student level, because we want to have more people working in these fields. And so one example of broader impact work that really resonated with me when I was thinking about it from a teacher perspective as a former elementary school teacher, and I'm a mom of a preschooler, there's a robot book that I found for kids that was developed by a research team at UC Berkeley. Denise will share that link with you in the chat. And this is just a great example that helped to inspire our own thinking about what broader impacts means, because our goal is to make research more accessible so that educators can understand it and also bring it into the classroom. And that includes understanding some of the computer science research concepts and thinking a lot about how can our students better understand them and have connections between researchers, teachers, and all the stakeholders in this work, because they play such an important role. So that's the behind the scenes as to what had us thinking about doing the workshop. And then we also just wanted to offer something tangible for educators to take back in the classroom. So we know that these now robots that this research involves, they're really expensive, and a lot of support would be needed for teachers to actually leverage them in their classrooms. And it might not really be realistic for every classroom to have one. So we wanted to think about a way that we could bring elements of the research to you without having that technology piece. But the first step was that we had a beginning phase one of our study where we talked to teachers ranging from preschool all the way through high school and just asking them about their experiences with professional learning for STEM and computer science education, as well as the ways that research has been disseminated to them. And then we got their recommendations for different types of professional learning programs that would really make it more impactful. And we tried to integrate some of those into today's session. So today's goals obviously are wanting to have some professional learning occur, but we also want further collaboration. So we have a lot of opportunities for discussion. We have a twofold goal here. We're seeking your feedback on the actual format and model of the workshop, but we also want to think about the impact of this workshop and if potentially it could be integrated in classrooms with students or with other teachers for professional learning and how that might impact practice. So we're going to ask that you wear two hats as you're thinking a lot about this. One hat be the learner. If you were a student who was not really familiar with all these computer science concepts, would this be a way that you might be able to be more familiar? And as well, if you were the teacher and thinking about the role of a researcher, would that help you better understand the research and allow you to have questions and follow up directly with researchers as an effect of this? So today we have some guided activities to make it more inquiry-based, immersive, and we liked this idea that some of the teachers mentioned in phase 1 of our study about a turnkey curriculum or a make and take. So we wanted to provide some activities that potentially could be adapted and remixed and used in some way in the classroom. So that's what we're seeking your feedback on and also hoping will make it more immersive for you. And then the collaborative discussions and our feedback survey about the model of the workshop itself. So I want to just clarify that this is inspired by a project that's working with Now Robots for Teaching and Learning in Math. We are not the actual research team who's conducted this research, but we have collaborated and worked directly with them to develop this workshop. So we're going to jump into our terminology.
Yeah, so this slide gives a little bit of an overview of some of the concepts we'll be talking about today. I'm not going to go through all of them right now, but they're going to come up throughout our conversation. And if some of these are not familiar to you, that is definitely okay. Like Cassandra just mentioned, we really like that everyone's coming in with different levels of expertise and areas of knowledge. So we'll just be trying to make sure that everyone's following along. And if you do have questions, definitely ask us for help, ask for support. We're definitely ready to do that. And on the other hand, some of these, or maybe all of these terms are familiar to you. It might feel a little too simple, but from that end, we want to try and remind you to put on that learner hat and remind yourself to think about this the way a student might if you were to implement these activities in the classroom.
So when you were talking about robots, you were talking a lot about building the robots and the programming. And the foundation of this research is based on learning by teaching. So we know just from having to explain a concept to someone else, whether that be another person or a robot, can be more engaging and motivating, but it can also be more challenging because you have to think about how to clearly communicate it. And that's part of the learning process. And so this research in particular looks at teachable robots. And this concept of a teachable robot is a social robot for learning that's based on that principle of learning by teaching. It's actually already been found that learning by teaching with robots can improve domain learning and student self-efficacy and motivation. So if you think about students who might be more shy or quiet, reserved in the classroom, what are ways that maybe they might be more comfortable with this agent? In the studies that we're sharing about today, the students were taking turns teaching a robot how to solve math equations. So you might not have heard that term teachable robots, but in the research literature, some of the other terms are chatbots, voice assistants, intelligent virtual assistants, conversational agents, robot companions, AI robot, but they're all similar. So some examples, like the first chatbot, Eliza from MIT or Watson from IBM. The idea is that personified and they exemplify human feature. And so Watson was known to beat human Jeopardy champion Ken Jennings, but you can also think about like Alexa and Siri and how we interact with them. So obviously there's a lot of different ways that we can explore the social dialogue system between these agents and robots and humans. But for this broader impacts portion that we're doing, we wanted to understand how do these work and what are potential future uses? So if you were interacting with your students and telling them like, how does a robot actually work? So again, putting on that hat, ways we can bring students into understanding what's behind the technology. And so we thought we'd just share with you an example. This is where the robot was referred to as Nico.
I really want to go swimming with my friends, but I need to put some waterproof paint on first. I need help figuring out how much paint to put on my legs and torso. Can you give me a hint for how to figure out the first part? Step 1.
Okay, Nico, so remember the ratio of 6 to 2, okay?
Okay, I will remember the ratio of 6 to 2.
So what is 12 divided by 6?
12 divided by 6 is 2.
What is 2 times 2?
2 times 2 is 4. So do we use the ratio between the 6 and the 2?
Yes, because 6 times 2 is 12. Therefore, 2 times 2 is 4.
Okay, I will put the answer as 4.
As you saw in that example, the student is actually asking the questions rather than like a tutoring system where the tutor would be like the teacher role. So the student is teaching the robot through the questioning and that process. And we'll talk a little bit more about that, but we wanted to explain to you the social behaviors design.
Yeah, so in order to make these interactions more realistic for the students, there's a lot of different programming that we have to tackle here. And there's a lot of social forms of dialogue that you might not think of, but turn out to be pretty important in this research. So, for example, complimenting the student, like saying you're doing a great job, calling them directly by their name, just being agreeable in general, and then incorporating positive phrases and politeness to make the interaction feel a little bit more human-like. You'll also notice sometimes the robot will say, let's put the answer instead of I need to put the answer. So using inclusive language that helps build the human-like personality of the robot as well as the rapport with the student. Then this slide shows entrainment. So that is when two people in regular conversation are talking to each other. If they're getting along well, their speaking patterns tend to emulate each other. So you can see that in the diagram over here. So that is one of the things that our researchers implemented with Nico to try and match the students' pitch levels as a way to make that conversation move smoothly as well.
And some of these things that Serena was mentioning about social forms of dialogue, the research team was also thinking a lot about pedagogy, like how do we form the questions, but make it in a way where the student is leading the conversation and thinking about how students might respond. We're going to talk more about how the robots work in this case and how it might differ from other newer forms of AI, like you might be familiar with ChatGPT and large language models. We'll talk about that moving into our workshop. Again, we wanted you to explore the role of a researcher. So thinking about what are the computer science concepts that have to be understood to do some of the research methodology and to understand the findings. And another layer is thinking about it as a learner. So the starting point for the design of these activities that we looked at are the K-12 computer science framework and the 5 AI big ideas for thinking about classroom integration. We also align our activities with the ISTE standards for educators and students. So those are listed here, and there could be others that are addressed, but these were just some that really seem to align the most. And the primary concept that we're working on through this research and through this professional learning is natural language processing. So the activities are really to help build that understanding of natural language processing. How does it work? And how did the research actually impact students when the code was used with the natural language processing in mind and the social interaction pieces of it? So we're going to begin with breakout activity, which is our first of 2. And you will have an opportunity to look at a math problem similar to how the students did in this, and thinking about language and keywords that are used in the example, and how we can sometimes have different interpretations of how we solve a problem and the way we communicate it. Then as a next step of the activity, we're going to look specifically at the script that was used to program our robots. So we have a very simplified table format of the script, or we also have the AIML code, which we're going to talk a little more about what AIML code is and how it works. But we have some questions for you to be answering as you're looking through these activities. So the goals are thinking about what were some of our design and implementation challenges with building this robotic dialogue system for learning specifically, and how does it work? So let's dive deeper into the first activity so it's clear what everyone's doing. We're going to open up breakout rooms, and first step is just looking at one of the example ratio math problems for the students that were actually involved in the research. And we know you already know how to do ratios and answer these kind of problems. So that's not the focus of this, but the focus is on what concepts and keywords and terminology would be important if you were trying to explain this to a robot and the robot had to actually understand and respond back as a natural conversation. So you're going to read through that problem and each take turns answering the question of how you would explain it with your own strategies and terminology. And the next level of that is you're going to look at discussion questions here, like what strategies were similar that you use, which were different, were there any differences in the sequence of steps for solving the problem, and then what was common math terminology used. After we get through that, we're going to talk more about how to identify the keywords and phrases within the script. So we're going to just focus first on this math problem that's here on slide 18 and the keywords and terminology. And we're going to give you 10 minutes to talk through what are things students would have to understand, what are things the robot would have to understand. And you're wearing your learner hat in this particular activity as well as your teacher hat.
So now we're going to start going through some of these discussion questions. The first question is, what problem-solving strategies did you find similar? Did you find a lot that were different? Our next question is there a difference in your sequence of steps? And then finally, we want to know what kind of common terminology you all were using. The reason we picked a problem like this is because there are so many different ways to solve it.
I think that drives to what in the first group we were talking about how the students were taught to communicate it or what strategies that they were taught. I know I taught elementary and it was all about teaching them to get to the algorithm. But before you can get to the algorithm, you have to conceptually understand what the algorithm actually means, what the representation is. So I think that's where we might run into some questions here with student misconceptions or what students' understanding is and how they explain it. And that's where programming the robot, you have to really consider all these different ways that they might respond with strategies and terminology and how are they taught. And I know group 2 also was experimenting to see how comprehensive the question was. Like, does ChatGPT understand it and what kind of response does it give you? So we're going to leave you thinking about that at this point because we are going to look more at this problem and the dialogue that our robot was using. So part 2 of our activity is where we're going to go back and actually look at an example script between a student and the robot, Emma. And we have 2 different options. You can look at the table format, which is basic just to help you understand where the keywords were, or you can look at the actual AIML code version. So the activity, if you were a teacher that had no computer science background, that might maybe give you some understanding of natural language processing. That's the point behind it. Or if you were a student trying to understand how the robots work. We're trying to think about the learner hat. If you didn't have that foundation, you can also look at questions the student who's learning about the computer science concepts would go through to understand them. But we also have some reflection questions, like how would students experience this kind of activity and gain content knowledge? Or what are ways you could remix this activity to actually use in the classroom? And then thinking more broadly, if this was a format for professional learning, could this help educators and students understand the research and understand the findings more accessibly? And could this format create more dialogue between educators and researchers? Let's talk through what some of the things were so you can share with the other groups.
So in group 1, we were talking about, as we looked at the script, we were wondering where
We'll move into our final activity and we have to demystify and share some of the limitations of our now robot because I know that's come up a lot in the conversations and we'll come to our finite state machine slide.
So something you all probably were noticing as you were looking through the scripts, the AIML code, is that everything is already planned out. And that's because Emma, this robot that we're talking about here, is not using machine learning. More so, it's a finite state machine. And so what that means is that it's a model that can really only exist in one mode or one state at a time. So a really common example here is like a turnstile, where it can take only a few kinds of inputs. You can either be putting in a coin or you can be pushing it. And then there's only two kinds of outputs. It's either locked or it's unlocked. Um, and so that's sort of the case with Emma here, is that if you say the right thing and spell it exactly correctly, then it will give you its programmed response. And if not, there's a catch-all default response that sort of indicates that it didn't understand what you said. Uh, so you're going to notice that in our later activity that you've got to be very careful with the language that you're using, because it's pretty easy for it to get stuck just in case it hasn't been programmed to address whatever you said. And so if we go to the next slide, that one addresses a little bit more about machine learning.
And I was just going to add before we jump to that. So, in the group two that was talking about limitations of Emma, there was conversation about if the student doesn't have a grasp of the math concept and they're trying to explain, language can be a barrier or a lot more challenging than just the solving of the problem. So, we were discussing how potentially the student has that understanding of the math, but now they have to think about how would you clearly explain it and how does that fit within the computational thinking of programming the robot or communicating it to the robot. So that was really interesting. And then also, how does Emma notice if they don't understand and what happens? Because some of her responses are kind of vague, as we have noted.
But I just want to talk really quickly about what machine learning is and how that contrasts pretty significantly with the finite state machine model that we're using for Emma. Probably a lot of you are familiar with the term, but I just want to explain it a little more broadly. It is a form of artificial intelligence, and really the hallmark of machine learning is that it can remember decisions that it's made in the past and keep track of those outcomes in order to inform its future decisions. That's the whole learning aspect of this. And so that definitely makes it different from a finite state machine, which doesn't remember previous states or anything like that. So a really common example for machine learning is just classifying pictures of cats and dogs, right? The model is trained on those different pictures to be able to recognize them, and then it tests itself by using a whole new set of pictures with the inputted correct answers. So then it can identify where it's right, where it's wrong, and improve its accuracy from there. I think a really important point to bring up here is ChatGPT. We've mentioned a couple of times now, it does use machine learning. That's what all large language models are using right now. And so a question that's come up for us before is why we aren't using LLM instead of Emma or a conversational agent the way we're doing for this research. The answer is honestly just because we haven't been able to develop the control over ChatGPT yet. We know it's not completely predictable, it's not always accurate, it's not safe enough to be using with students, especially if they'll be guiding them in the wrong direction. And like Cassandra just mentioned, we have more of a control over the language we're using in teaching. So that's why we're leaning more towards the conversational agents at this point.
Yeah, I know we also talked about like this research really it started pre-machine learning models like ChatGPT really exploding more recently. But even then, the researchers themselves, they were really trying to embed pedagogical knowledge that was built into the system and the way the scaffolding would happen in the learning context. And those are layers no one who's developing these large language models is really applying right now. And so that's worth noting. Besides the inaccurate information that can come from it or biases, that there's also the pedagogical aspects of how we can program something like Emma. And then we talked about the cost, right? So we decided that since we can't have these robots in every classroom, that we could actually think about these conversational agents and chatbots. And Pandora Bots actually does have those features. And even since then, it's getting more and more developed. So I'll let Serena touch upon that next.
And I'm just thinking about the question asked in the chat, which one has more bias? I think that's a really interesting question, right? Because machine learning models, their bias is based on the data they're trained on. So in the case of ChatGPT, it's like most of what's on the internet. So that's definitely a question of what bias that leads towards. And then, of course, the bias of writing a conversational agent, that's up to the programmers and where they're biased. But I also think in that regard, because it's just finite states, there's not necessarily Well, there is an aspect of bias, but I don't know. There's only a certain number of answers there can be for that case. So that's a really interesting question, something fun to consider. This slide here talks a little bit about Pandora bots, which is what we used to program Emma. If you looked at the AIML script, that stands for Artificial Intelligence Markup Language. It's a language that we're using here. I'm just going to go over it very briefly, but you can see the patterns. Those are things that Emma can recognize. So for example, travel in this one, that would be the word Emma can recognize and then is programmed to respond directly to that. And we're going to have an activity in a little bit where you can directly interact with Emma. So it'll be important for you to try and remember to use specific keywords that come to mind, words that you think Emma would be able to recognize. So our next activity is going to involve interacting with two different versions of Emma. I'm not going to tell you what the difference is, but I think you'll be able to figure it out pretty quickly once you start working with them. Definitely be careful with your spelling, using your keywords. You get stuck somewhere, or if Emma gets confused, which is very potential, that's definitely okay. Take note of that and see where it might have gotten stuck, what other prompts you might have been able to use. You can also close out and open it again if you want to just start over and see what happens when you try something new. And then try and notice the difference between the two simulations. Just try and make your way through each one. It's the same math problem that we've been talking about, so hopefully you're familiar with it now. You have a couple of different ideas for how to solve it, and I'm excited to see what findings you'll have.
The second one was designed with a more social language to be more human-like and more personable. And the first one, very short and direct, but it could easily get tripped up and not really go anywhere in the conversation, which some of you experience, but that is more likely in the chatbot version, I think, than talking verbally, but still a problem with the way that she's designed and her limitations. Serena, was there anything you wanted to add about that?
No, I think that's right. So when we were putting this together, we were looking at the keywords that they already had available to them. And I really like the idea of like providing a list of words that Emma already knows. So we had talked about that too, like making a word bank or something available for students to pull from, or like having the script right there in front of them. So I think that's definitely a good idea to think about going forward.
And I think the frustration piece is a valid point because there's still some limitations generally with AI. And it's not a human. It's not going to replace a teacher in the classroom who has that expertise or who can pick up on cues and things that these devices can't. But then that there could be some benefits of having an agent to communicate with about a problem or something that you're doing in this context that could be beneficial. What we're trying to do here is to think about what's practical in the classroom and what's not, and bring in conversation between the researchers and the practitioners, because the researcher might consider how teachable agents work, what are students' reactions to them, and their perceptions, and the types of prompting that's used. But then, is that really realistically going to impact education in a way that supports the learners or the teachers? Or is there more practical uses of what we're doing with some of these tools and what we're exploring? So part of what we want in this model is a way that the researchers could give the teachers a better understanding of what they're thinking about and exploring. And then the teachers could weigh in and say, hey, I don't think that's actually going to work with students, or this is not something that's applicable. So we'd like to see more of that conversation happening between researchers and practitioners. We also were trying to think, could there be other extensions from what the research was doing where students could learn more about behind the scenes of the AI and the conversational agent or the teachable robot, assuming that they don't know how these chatbots work and that there are limitations because they are programmed by a person, and a person has to account for all the possible dialogue that could happen. However, large language models, as we've talked about, are not controlled enough and considering biases and thinking about pedagogy enough that we want to use them with students. So some other things we talked was thinking about the dialogue itself or how to program dialogue. So I looked at if we had Scratch and we had two sprites talking to one another that could use literacy skills, but then building off of that with an agent where you could test it out and how does it work when someone else interacts with it. And so Pandora Bots itself too, even now has avatars where you could create the agent and use it in other contexts, even now, like you said, outside of math, but exploring how to make it more human-like. Those were just a couple examples we were thinking about. If there was an elementary school teacher wanting to do this versus a high school teacher, what are ways that we could make it relevant to everybody? And what are the learning outcomes, which I think we emphasized in our conversations with you, that the math really didn't become the main point here. Instead, it was more about the language and the terminology and how that works to create this conversation. And then who does that really benefit? Does it benefit the shy students or the students who are having difficulty, or does it benefit the students who maybe need more challenge and how to explain it clearly? And so these are all really good things to be thinking about when it comes to the learning outcome and who we'd be bringing this into the classroom for potentially. And then the other piece is ethics. We need to create more awareness, AI literacy for students, for teachers about how these things work, because they don't understand necessarily behind the scenes. And that's why we want activities like this where at least they can begin to understand who they're talking to. Is it actually a person? And so AI Circles, one of our sub-communities of Circles, put together suggested policy resources. And even since we developed this presentation, I know UNESCO recently proposed policy for teachers with AI using large language models and also for students. So those are all worth exploring and thinking about how to integrate it into conversations with students. So we've talked about this in our small groups, the different benefits and challenges. If we had teachable robots in the classroom in the future, the research team currently is exploring two students collaborating together with the robots. These agents could help improve group dynamics. So these are the overall research findings. Teachable agents can improve learning. Multimodal social behaviors can improve learning. So looking at pitch and the dialogue. Serena talked about inclusive language and using praise to build self-efficacy with students, that what was proven to make a difference and improve the learning. And then looking at the balance of participation and making sure everyone's having an equal chance to speak. Questions are, and what happens if the robot or the agent refers to the student, and how does it balance that conversation? And can it learn? We want to leave with these reflection questions about the workshop itself and other feedback you might have for us. And I do want to acknowledge our research team. This work wouldn't be possible without all of these people who've been working on the research projects over the years that we've presented to you today. And then on our next slide are some of those publications that have come from this work. So you're welcome to dive deeper into it. And you're welcome to take the presentation slides and all the resources and share them with other educators. That's our whole purpose of this. And thank you so much again for being here.
Thank you everyone for joining.